In this video, I'll walk you through everything you need to know before building a gaming PC. From choosing the right components to understanding what they actually do, how do they work together, and most importantly, what to avoid. Whether you're building for gaming, editing, or a mix of both, this guide will help you make informed decisions and avoid costly mistakes. First thing you need to decide is the purpose of the build. If you want to use it for programming, video streaming, or office work, then you'd require less configurations as compared to an editing or gaming PC. For example, an i5 processor with 8GB of RAM and 256GB SSD would be sufficient for most programming and other such tasks. For 1080p gaming and editing, you could work with the latest Gen i5 or Ryzen 5 7600, but an i7 or Ryzen 7 9700X would be better suited. And while 16GB DDR5 RAM would work, having 32GB of RAM is recommended. As editing and gaming are both graphic-intensive tasks, you absolutely would need a dedicated graphics card. After deciding the purpose of your build, you can start selecting the components. Let's start with the processor, also called the CPU. It's the brain of your system. Everything you do, opening a game, browsing the internet, or editing a video gets processed here. Now, CPU have something called cores and threads. Think of cores as workers. More cores means more tasks can be done at once. Threads are like virtual helpers that make each core handle multitasking better. For gaming, you don't need a crazy amount of cores. Modern i5 or Ryzen 5 CPUs are usually enough, but if you're into video editing or 3D rendering, go for more cores and threads. Clock speed tells you how fast the CPU can work, and cache is like a small super-fast memory built into the processor for quick access to important data. Next up is the GPU or graphics card. This is what really matters for gaming. It handles visuals, frame rates, lighting, shadows, textures, everything you see on the screen. You'll come across terms like VRAM, which is the memory inside your graphics card. More VRAM means better performance in high-resolution games. Most modern GPUs come with GDDR6 memory, while newer and higher-end ones have GDDR7. I prefer NVIDIA GPUs as they have better ray tracing capabilities and better frame generation via DLSS. If you're gaming at 1080p, 8GB VRAM is usually fine with RTX 3060 or 4060. But for 2K or 4K gaming, go for either 12GB or more VRAM. Also, if it's suiting your budget, get an RTX 40 series GPU as it comes with DLSS 3 support, which enhances frame rates on supported games for a smoother gaming experience. I recently built my gaming PC and used the RTX 4060. You can also check out the video from here. Now, to make your CPU and GPU work together, you need a motherboard. This is the central hub where everything plugs in. It connects all your components like CPU, RAM, storage, GPU, and powers them. When choosing a motherboard, make sure it matches your CPU type, Intel or AMD, and it should support RAM generation, DDR4 or DDR5. A good motherboard should have enough USB ports, a few PCIe slots for your graphics card, and support for M.2 SSDs. If you want a built-in Wi-Fi and Bluetooth, look for boards that mention it in the specs. Then comes RAM or memory. It helps your PC handle multiple tasks at once. For gaming in 2025, 16GB RAM is necessary, whereas 32GB is the sweet spot. If you're editing videos or using heavy software, get at least 32GB of RAM and 64GB if you want a smooth editing experience. RAM comes in speeds like 3200MHz, 5200MHz, etc. Faster RAM can slightly boost performance, especially in editing and multitasking. So skip DDR4 and go for DDR5 RAM in 2025. Storage is where all your games, softwares, and files live. SSDs or solid-state drives are much faster than HDDs or hard drives, and they help reduce game load times and boot your system faster. Go for at least a 500GB or 1TB NVMe SSD if your budget allows. NVMe is just a faster version of SSD that connects directly to your motherboard. Now, let's talk about your power supply unit or PSU. This powers your entire system. Don't cheap out on this. Get a power supply from a good brand with 80+ bronze or higher rating. This rating basically refers to the minimum % of efficiency it offers. For most mid-range builds, a 650-watt power supply is more than enough. If you have a powerful GPU like an RTX 4070 or higher, you might want to go for the 750-watt. The cabinet or case houses everything. It doesn't directly affect the performance, but airflow, cable management, and aesthetics matter. Choose one with good ventilation, pre-installed fans, and enough space for future upgrades. A glass side panel is a nice bonus if you like showing off your build. To keep your CPU cool, you can either use the stock cooler which comes free with some CPUs or go for an aftermarket air or liquid cooler. For most gamers, a basic air cooler with 120mm fan is enough. But if you're overclocking, doing high performance tasks, or you live in a hot climate, then you can opt for liquid cooling as it has superior thermal performance. But it does take more space and has multiple points of failure, such as pumps, hoses, or coolant degradation over time. Before buying anything, make sure that all the parts are compatible. Use websites like PC Part Picker. It can alert you to compatibility issues. Also, check the size of your case, number of fans, and whether your PSU cables match the GPU and motherboard connectors, etc. Once you have all your components, building a PC is like assembling Lego, but with wires. Start by installing the CPU on the motherboard, then add the RAM, storage, and cooler. Fit everything inside the case, connect your power supply, plug in all the cables carefully, and finally install your GPU. After that, connect your motherboard, keyboard, mouse, and then install Windows. That's it. You have built your own gaming PC. It is one of the most satisfying tech experiences, and you'll learn a lot along the way. If you have any questions or need help picking parts for your build, feel free to drop them in the comments. And if this guide helped you, don't forget to like and subscribe for more tech videos like this. See you in the next one.